The German engineer ran his hand along the hull of the American tank. Something was wrong. Not wrong with the tank. Wrong with everything he had been told about American manufacturing. It was April 1943. The tank sitting in the Kummersdorf proving grounds had been captured in Tunisia 2 months earlier. Serial number USA 3067641. The Americans had named it War Daddy 2. German High Command wanted a complete evaluation. They wanted to know the Sherman's weaknesses. They wanted firing tables showing exactly where to hit it. The engineer had spent 3 weeks examining every component. And what he found wasn't weakness. He ran his fingers over the welds. They weren't just strong, they were clean, uniform, machine-made. It wasn't just a manufacturing philosophy that terrified him. It was the realization that while Germany was crafting masterpieces, America was printing tanks. War Daddy 2 had been captured on February 22, 1943, 8 days after the Battle of Sidi Bou Said began. That battle was a disaster for the Americans. German panzers had smashed into the 1st Armored Division and sent them reeling back toward Kasserine Pass. The tank belonged to Company G, 3rd Battalion, 1st Armored Regiment. During the chaos of the retreat, the crew had abandoned it. Maybe they ran out of fuel. Maybe they took a hit that disabled the track. The records don't say. What the records do say is that German recovery teams found the Sherman intact. And unlike most captured tanks, this one started on the first try. The Germans drove it over 200 miles to Tunis, 4.5 days across the desert. No breakdowns, no mechanical failures. They loaded it onto a ship and sent it to Germany. High Command wanted their best engineers to tear it apart. What those engineers found would change how they understood the war. Kummersdorf was Germany's premier weapons testing facility. Located 20 miles south of Berlin, it had been the birthplace of the German rocket program and the testing ground for every major Wehrmacht weapons system. The best engineers in the Reich worked there. They had evaluated captured Soviet T-34s in 1941 and helped design the Panther as a response. Now they had their first American medium tank. Initial expectations were low. German intelligence had dismissed the Sherman as a mass-produced inferior design. Thin armor, weak gun, built by a nation that had never fought a modern tank war. The engineers approached the Sherman with the arrogance of artisans inspecting a cheap knockoff. They expected sloppy welds. They expected brittle steel. They wanted to laugh at the crude American attempt to build a war machine. They had their pens ready to write a scathing report that would make High Command smile. They started with the armor, measured every plate, calculated every angle, stenciled the numbers directly onto the hull in white paint. The armor thickness was adequate but not impressive. 51 millimeters on the front hull, 38 millimeters on the sides. A Tiger could punch through it at over a mile. Then they opened the engine compartment. The Continental R975 radial engine sat in the rear of the hull like an aircraft engine that had been dropped into a tank, because that's exactly what it was. The Americans had taken a proven aircraft power plant and adapted it for armored use. 400 horsepower, air-cooled, designed for reliability at altitude where mechanics couldn't reach it. German engineers noted the power-to-weight ratio immediately. The Sherman weighed 30 tons. The engine gave it 13 horsepower per ton. The Panther weighed 45 tons with a 700 horsepower engine, only 15.5 horsepower per ton, barely more than the smaller American tank, despite weighing 50% more. But power wasn't what impressed them. Any nation could build a powerful engine. What impressed them was the maintenance access. Every major component could be reached through large hatches. Oil changes took minutes. Spark plug replacement required no special tools. A mechanic with basic training could keep this engine running indefinitely. German tank engines required factory-trained specialists for routine maintenance. The Maybach HL230 in the Panther had known cooling problems that caused engine fires. Replacing one required a crane and a full day's work. The Americans had built a tank that could be serviced in the field by anyone. The Germans had built tanks that needed to be shipped back to factories. The engineers kept examining, and it kept getting worse. It was the sound that stopped them, or rather, the lack of it. When they ran the powertrain, the German engineers were used to the screaming whine of spur gears fighting against friction. The Sherman hummed. One engineer called his colleagues over, unable to believe what he was hearing. Herringbone gears. Precision-cut helical teeth that meshed smoothly under load. The kind of gears that lasted for thousands of miles without wearing out. German tanks used spur gears, straight-cut teeth that were cheaper to manufacture but wore out quickly under the stress of combat driving. The reason was simple. Herringbone gears required complex machining and specialized gear-cutting tools that Germany lacked. The tooling used tungsten carbide, a strategic material in short supply due to Allied blockades. Germany reverted to spur gears to save manufacturing time and reduce tooling wear. The Sherman's transmission could handle 3,000 miles before needing an overhaul. The Panther's final drive had an average lifespan of around 100 miles. Not 100,000, just 100. A Sherman could drive from Normandy to Berlin under its own power. A Panther could barely make it from the rail yard to the front lines. The engineers documented everything, but they weren't prepared for what came next. The 75-millimeter gun had a small box attached to its mounting. Electrical cables ran from it to a gyroscope near the gunner's position, a gun stabilizer. The Americans had put a gyroscopic stabilization system in a mass-produced tank. German engineers were astounded. They had experimented with stabilizers but never managed to miniaturize the components enough for tank use. The precision required was beyond their manufacturing capabilities. The Westinghouse system wasn't perfect. It only stabilized in the vertical plane. It didn't allow true shoot-on-the-move accuracy in the modern sense, but it did something far more valuable. It kept the gun roughly on target while the tank moved, which meant the gunner could fire accurately within seconds of stopping. German tanks needed 10 to 15 seconds for their suspensions to settle before the gunner could aim properly. In a tank duel, the first accurate shot usually won. The Sherman could get that shot off before a German tank had even stopped bouncing. The Germans examined the gyroscope and servo motors. They calculated what it would take to replicate the system. The answer was that they couldn't. Not with their current industrial base, not with the materials available, not with the precision manufacturing they had. And they still hadn't discovered the worst part. In June 1943, War Daddy II was transferred to Hillersleben for a demonstration before the High Command. They didn't want a reliability test. They wanted a show. Senior officers from across the Wehrmacht gathered to watch. Generals who controlled armored production priorities. Men who would decide whether to keep building Tigers and Panthers or change course. They set up a climbing test, a steep 30-degree slope of loose sand. The Panther went first. The German tank roared up the hill effortlessly. Its wide tracks bit into the sand. Its powerful engine never strained. The generals smiled. Then came War Daddy II. Its narrower rubber block tracks designed for road marching slipped on the loose surface. The engine whined. The tracks spun. The tank slid backward. The Sherman failed to climb the hill. The generals applauded. The demonstration had proven exactly what they wanted to believe. The failure on the hill at Hillersleben was a disaster. But not for the Americans. It was a disaster for the Germans. The generals looked at the hill and saw a victory. The engineers looked at the transmission and saw a warning. The Panther had won the sprint. But the engineers knew it would never survive the marathon. While the Sherman couldn't climb that specific sandy slope, it had just driven over 200 miles across the Tunisian desert under its own power, a feat the Panther could rarely match without breaking a final drive. The hill climb validated every wrong instinct the German military had. It convinced them to keep building high-performance thoroughbreds instead of reliable workhorses. The engineers who had spent weeks inside War Daddy II's engine compartment knew the truth. But they had just watched their generals cheer as the Sherman slid backward on loose sand. Nobody wanted to hear that the American tank's failure on the hill meant nothing compared to its success getting to the hill in the first place. And then Albert Speer came to see for himself. Albert Speer was the Reich Minister of Armaments. He controlled German war production. Every tank, aircraft, and submarine built in Germany came under his authority. Speer had a reputation for efficiency. He had tripled German weapons production in 1942 through reorganization and streamlining. He believed German engineering could outproduce the Allies if properly managed. Photographs exist of Speer examining War Daddy II. He studied the reports. He talked to the engineers, and he reached a conclusion that would haunt him for the rest of his life. Speer later wrote in his memoir that reports from Italy praised the Sherman's cross-country mobility. The American tank climbed mountains that German experts considered inaccessible to armor. The engine's power-to-weight ratio gave it superior mobility on level ground compared to German designs. But Speer understood the deeper problem. Germany was building complex machines that required a dedicated rail network to move. America was building a mobile force that could drive itself to the front line. Speer realized that no amount of German engineering genius could overcome a logistical philosophy that was simply better. The Sherman wasn't just a tank, it was a philosophy. American industrial philosophy prioritized three things: reliability, maintainability, mass production. German industrial philosophy prioritized one thing: technical superiority. American designers had made different choices. They accepted a less powerful gun because the 75mm was reliable and ammunition was plentiful. They accepted thinner armor because it reduced weight and improved mobility. They accepted a simpler design because it meant faster production and easier maintenance. Germany couldn't compete with that. Not because German engineers weren't brilliant, because German engineers had optimized for the wrong things. The men who understood this best weren't engineers, they were tank crews. Alfred Rubel commanded a Tiger I in the 503rd Heavy Panzer Battalion. He eventually became an ace with 57 confirmed kills. He knew exactly what German tanks could and couldn't do. His unit used captured Shermans for recovery and supply duties. Rubel later compared the Sherman to a reliable civilian car. You push the button, and they started. With the Tiger, there was always a procedure: checking fluids, warming up, worrying about the transmission. The Sherman just worked. German tank crews loved their Tigers and Panthers when they worked. The problem was they rarely worked. By 1944, German armored divisions reported operational readiness rates of 35 to 45%. More than half their tanks were broken down at any given time. American armored units maintained readiness rates above 85%. When they needed tanks for an offensive, they had tanks. The numbers told the story that German propaganda tried to hide. The Normandy campaign proved everything the Kummersdorf engineers had feared. During the retreat from Normandy, roughly half of all abandoned Panther tanks had been destroyed by their own crews after mechanical breakdowns, not combat damage, mechanical failure. Imagine the frustration of a German Panzer crew. You have the most powerful gun on the battlefield. You have the thickest armor. But you're standing on the side of a road in France, watching your transmission smoke, while a column of inferior Shermans drives past you to win the war. They didn't lose because they were outfought. They lost because they couldn't even get to the fight. The statistics from the Battle of the Bulge were worse. By late 1944, 60 to 70% of German heavy tank losses were non-combat related. Fuel shortages and breakdowns, not American gunfire. The engineers at Kummersdorf had seen this coming in April 1943. They had tried to look past the showy hill-climbing demonstration at Hillersleben and focus on what actually mattered: the internal components, the manufacturing philosophy, the brutal mathematics of reliability. They had documented every advantage the Sherman offered. They had written reports explaining exactly why American mass production would win the logistics war. Nobody had listened. The generals had watched the Sherman fail on a sandy slope and walked away confident that German engineering was superior. Germany couldn't adopt American manufacturing philosophy for reasons that went beyond engineering. The strategic materials weren't available. Herringbone gears required complex tooling that Germany lacked. Precision electronics required copper and rare earth elements. Allied blockades had cut Germany off from global supply chains. The production culture couldn't change fast enough. German factories were organized around skilled craftsmen who hand-fitted components. American factories used interchangeable parts and assembly lines. Converting one system to the other would take years Germany didn't have. The Nazi ideology got in the way. German engineering was supposed to be superior. Admitting that American mass production techniques were better contradicted everything the regime believed about Aryan technical superiority. So Germany kept building Tigers and Panthers, magnificent machines that spent more time broken down than fighting, technical marvels that couldn't compete with American quantity and reliability. Germany remained trapped, bound by an ideology that demanded perfection and an industrial base that could no longer afford it. America built 49,324 Sherman tanks during the war. Germany built approximately 6,000 Panthers and 1,347 Tigers. The production ratio was nearly 8-to-1 for medium tanks alone, and American tanks actually worked when they reached the front. A Tiger could destroy 5 Shermans in a single engagement, but there would be 6 more Shermans arriving tomorrow, and the Tiger would be broken down waiting for a transmission that wouldn't arrive for 3 weeks. The mathematics were brutal. German tankers achieved kill ratios that would have won any other war. But this war wasn't about kill ratios. It was about logistics. War Daddy 2 had shown the German engineers exactly why they would lose. A tank that started when you pushed the button, a transmission that lasted the life of the tank, an engine that any mechanic could service. Reliability beats perfection. Availability beats capability. Working beats superior. Every single time.